January 1942, the North Atlantic. At 2 a.m., the freezing wind howls across the deck of a merchant freighter as it plows through the swells of the mid-Atlantic Gap. In this desolate stretch of water, there are no escort planes to keep watch and no coastal patrols to offer a shield. The sailors aboard know they are in the Black Pit, a 1,000-mile-wide void where the long-range bombers of the Royal Air Force cannot reach. Below the surface, the grey wolves of Admiral Karl Dönitz's U-boat fleet are waiting in silence. Within minutes, the night is illuminated by the orange glow of a burning hull, another vital shipment of food and fuel destined for the bottom of the ocean. This was the reality of the Battle of the Atlantic at its most desperate turning point. Britain was being slowly strangled, losing more tonnage than its shipyards could ever hope to replace. The crisis demanded a solution that defied conventional logic, leading the British Admiralty down a path of scientific madness that would eventually result in one of the most bizarre engineering projects in the history of naval warfare. By the middle of 1942, the situation had reached a breaking point. Winston Churchill and the Allied High Command were faced with a terrifying mathematical certainty. If they could not close the mid-Atlantic Gap, they would lose the war. Traditional aircraft carriers were the obvious answer, but they were incredibly expensive, time-consuming to build, and required vast amounts of steel, a resource that was already being rationed to the point of exhaustion. The Royal Navy simply did not have the time or the materials to build a fleet of carriers large enough to protect every convoy. It was in this atmosphere of extreme desperation that a man named Geoffrey Pyke entered the fray. Pyke was not a naval officer or a professional engineer. He was an eccentric polymath and an inventor, with a reputation for thinking outside the boundaries of established science. He worked for the Combined Operations Headquarters under Lord Louis Mountbatten, and he had a vision that seemed like a fever dream born of the Arctic winter. Pyke's proposition was as simple as it was shocking. If Britain lacked the steel to build ships, why not use the one material the North Atlantic provided in abundance: ice? Pyke envisioned a massive, floating airfield carved out of a natural iceberg or constructed from massive blocks of frozen water. He argued that a ship made of ice would be virtually unsinkable. A torpedo strike that would shatter a steel hull would merely leave a small crater in a berg of ice, which could then be repaired with more water and a refrigeration unit. It was a radical solution to a radical problem. To the skeptics in the Admiralty, it sounded like a joke, but to Mountbatten and Churchill, it represented a glimmer of hope. They knew that traditional methods were failing. The U-boats were sinking merchant ships faster than the Allied shipyards could build them, and the air cover remained tethered to the distant coasts. As the sun rose at 11 a.m. over the London war rooms later that year, the plans for what would be known as Project Habakkuk began to take shape. The scale of the ambition was staggering. They weren't just looking for a small platform. They wanted a floating island 2,000 feet long, with walls 40 feet thick, capable of carrying an entire wing of heavy bombers. It would be a mobile fortress of frost, a literal island of resistance in the middle of the storm-tossed sea. Yet, as the scientists began their initial tests, they realized that plain ice was too brittle. It cracked under pressure and melted too quickly in the shifting currents. The project seemed destined for the scrap heap of history, until a breakthrough came in the form of a mixture made from wood pulp and water. This new material, named Pykrete, would change everything. It was stronger than ice, tough as concrete, and could be machined like wood. Looking back at this moment in the war, we see the true nature of innovation under fire. The Battle of the Atlantic was not just a conflict of hulls and torpedoes, but a war of endurance and imagination. Project Habakkuk remains a testament to the length a nation will go to when its back is against the wall. It represents the thin line between genius and insanity, a moment when the laws of nature were challenged by the necessity of survival. The frozen gargantuan that almost was reminds us that in the darkest hours of history, the most impossible ideas often become the only ones worth pursuing. The ice carrier was never just about a ship. It was about a desperate belief that even the ocean itself could be tamed to ensure the survival of the free world. September 1942, in a cluttered office in central London, a man who many considered a madman was about to change the way the British Admiralty looked at the frozen wastes of the North. Geoffrey Pyke was an eccentric polymath, a man who often went without socks and allowed his beard to grow into a wild thicket, yet he possessed a mind that thrived on the impossible. He was a protégé of Lord Mountbatten, the Chief of Combined Operations, who valued Pyke's ability to think beyond the rigid confines of traditional military doctrine. At this moment, the Battle of the Atlantic was reaching a fever pitch. German U-boats were strangling the British supply lines, and the mid-Atlantic Gap, a vast stretch of ocean beyond the reach of land-based aircraft, had become a graveyard for Allied shipping. Pyke's solution was as audacious as it was terrifying. If the Allies couldn't build enough steel carriers to cover the gap, they would build them out of ice. The initial concept was simple, but the physics were daunting. Pure ice is notoriously brittle and prone to shattering under the stress of heavy waves. Furthermore, large icebergs have a habit of rolling over as they melt, which would be catastrophic for a floating airfield. Pyke knew that for his vision of HMS Habakkuk to work, he needed a material that was as strong as concrete but as buoyant and cheap as ice. He turned to a brilliant molecular biologist at the Cavish laboratory named Max Perutz. Together, they began experimenting with various additives, eventually discovering that by mixing a small amount of wood pulp into water before freezing it, they could create a composite material with extraordinary properties. They named it Pykrete, a portmanteau of pike and concrete. This new substance was a revelation. By weight, it contained roughly 14% wood pulp and 86% water, yet it was remarkably resistant to impact. While a block of ordinary ice would splinter into 1,000 pieces when struck by a hammer or a bullet, Pykrete absorbed the energy. It could be machined like wood, turned on a lathe, and it resisted melting far better than pure ice because the wood fibers formed an insulating shell on the surface. To Pyke and Mountbatten, this was the ultimate weapon, a self-healing, unsinkable fortress that could be produced in massive quantities using the abundant forests of Canada. The most famous demonstration of this frozen miracle occurred during the Quebec Conference in August 1943. At 2 p.m., on a sweltering afternoon, inside the heavily guarded Chateau Frontenac, Mountbatten decided to shock the Allied High Command into believing in the project. He wheeled in 2 large blocks of material, one of pure ice and one of Pykrete. Before the eyes of Winston Churchill, Franklin D. Roosevelt, and their respective chiefs of staff, Mountbatten drew his service revolver. He fired first at the pure ice, which shattered instantly. Then he fired at the Pykrete. The bullet did not penetrate. Instead, it ricocheted off the frozen block, buzzing through the room like an angry hornet, and narrowly missing Admiral Ernest King. The generals were stunned. The demonstration proved that this was not merely a scientist's daydream, but a viable structural material that could withstand the brutality of modern warfare. The planned dimensions for the Habakkuk were staggering. It was to be 2,000 feet long and 300 feet wide, with a hull 40 feet thick. It would displace 2 million tons, making it the largest vessel ever conceived by human hands. It was designed to be powered by a massive internal refrigeration system that would circulate cold brine through pipes embedded in the Pykrete, ensuring the ship never melted, even in warmer waters. It was a vision of a future where the laws of nature were bent to the will of human ingenuity. Ultimately, the project was overtaken by the rapid pace of the war. By 1944, the development of long-range fuel tanks for aircraft and the closing of the mid-Atlantic Gap meant that the desperate need for a floating ice island had evaporated. The costs and technical hurdles of building such a gargantuan structure proved too high for a military already stretched to its limits. Yet, the story of Pykrete and the birth of the frozen fortress remains one of the most compelling chapters of the conflict. It serves as a testament to the era's radical creativity, where the line between a madman's ranting and a genius's solution was virtually non-existent. The legacy of the ice carrier is found in the realization that there are no limits to what the human mind can conjure when faced with total annihilation. It reminds us that progress is often fueled by the most unconventional thinkers, the ones who look at a block of ice and see a battleship. Though no Pykrete carrier ever sailed into battle, the spirit of the project lingers as a reminder that the greatest defense against darkness is the light of a truly original idea. The frozen gargantuan that almost stands as a monument to a time when the world was willing to try anything, even turning the very sea into a shield, to ensure that freedom would not perish from the earth. September 1942, London. In the smoke-filled rooms of the British Admiralty, a proposal was circulating that sounded more like Jules Verne than modern naval doctrine. While the Battle of the Atlantic reached a fever pitch, with German U-boats strangling the island nation's supply lines, an eccentric scientist named Geoffrey Pyke was whispering of a fleet made not of steel, but of frozen water. Pyke was a man whose mind moved faster than his contemporaries could often follow, and his vision was for a massive 1,000-ton aircraft carrier carved from an iceberg. It was a concept born of desperation and genius, aiming to close the mid-Atlantic gap where Allied planes couldn't reach. And it found its most powerful champion in the Prime Minister himself. Winston Churchill was never one to shy away from the radical. When Lord Louis Mountbatten, the Chief of Combined Operations, brought Pyke's memorandum to his attention, Churchill was immediately captivated. By 11 a.m. the following morning, a directive had been issued with the Prime Minister's characteristic "Action this day" stamp. Churchill saw the potential for a floating fortress that could not be sunk by torpedoes, a vessel that could be repaired simply by freezing more water into its hull. He dubbed the venture project Habakkuk, a name taken from the Hebrew Bible. "Behold ye among the heathen, and regard and wonder marvelously, for I will work a work in your days which ye will not believe, though it be told you." The initial problem, however, was physics. Pure ice was too brittle. It would shatter under the impact of the massive Atlantic swells or the explosion of a German torpedo. This was where science met the miraculous. Max Perutz, a molecular biologist, discovered that by mixing water with about 14% wood pulp before freezing it, the resulting material, named Pykrete, possessed the strength of concrete but remained as buoyant as ice. It could be machined like wood and resisted melting far longer than its natural counterpart. Pykrete was the secret weapon the project needed, and with the concept proven in a laboratory, the British government looked across the ocean for a place to build a prototype. January 1943, Alberta, Canada. In the secluded wilderness of Jasper National Park, far from the prying eyes of Axis spies, a small army of workers began the impossible task on the surface of Lake Patricia. This was to be a scale model, 60 feet long and weighing 1,000 tons. Designed to test the structural integrity of a frozen hull and the cooling systems required to keep it from turning back into a puddle. The Canadian government provided the labor, much of it consisting of conscientious objectors who found themselves building a secret weapon in the middle of a frozen lake. They worked through the biting cold, layering blocks of ice and wood pulp, while a complex network of refrigeration pipes was woven through the structure like a nervous system. By 2:30 p.m., on a particularly frigid afternoon, the prototype was functional, proving that a refrigerated hull could survive the rising temperatures of spring. The success of the Canadian experiment led to one of the most famous demonstrations in military history during the Quebec Conference in August 1943. At 3 p.m., inside a heavily guarded room at the Fairmont-le-Château Frontenac, Lord Mountbatten stood before the high command of the Allied forces, including General Dwight D. Eisenhower. To the shock of the assembled generals, Mountbatten drew his service pistol and fired a shot at a block of ordinary ice, which shattered instantly. He then turned his weapon on a block of Pykrete. The bullet did not penetrate. Instead, it ricocheted off the surface, buzzing around the room like an angry hornet and narrowly missing the sleeve of Admiral Ernest King. The message was clear. Pykrete was a viable armor. Yet, as the project moved from prototype to the planning of a full-scale, 2-million-ton behemoth, the realities of total war began to settle in. The sheer volume of wood pulp required would have crippled the paper industry, and the amount of steel needed for the refrigeration units alone was enough to build a traditional carrier. Furthermore, the introduction of longer-range aircraft and the liberation of the Azores gave the Allies the air cover they needed without the need for a floating island of ice. Project Habakkuk never saw the open ocean, and the prototype at Lake Patricia eventually sank to the bottom of the lake as the refrigeration was turned off, leaving only a skeletal remains for modern divers to explore. However, the legacy of the project is not found in the ice that melted, but in the audacity of the attempt. It serves as a testament to an era when the stakes were so high that no idea was too strange and no dream too vast. It reminds us that in the darkest hours of human history, the most powerful tool at our disposal is not the gun or the bomb, but the unbridled imagination of those who refuse to believe that the impossible cannot be achieved. The ice carrier remains a haunting shadow of what might have been, a monument to a moment when humanity looked at the very elements of nature and saw a way to deaf the future of civilization. August 1942, in a nondescript office in London, the eccentric visionary Geoffrey Pyke stood before a group of skeptical military planners to unveil a blueprint that defied every law of naval tradition. He was not proposing a ship built of steel and rivets, but rather a leviathan forged from the very water it would sail upon. This was the birth of the Habakkuk design, a proposal for an aircraft carrier 2,000 feet long and weighing a staggering 2 million tons. To put that in perspective, the largest modern nuclear supercarriers barely reach a 20th of that displacement. The sheer scale of the project required a total rethink of everything the Admiralty knew about buoyancy, structural integrity, and the physics of the sea. The secret to this frozen fortress lay in a material Pyke named Pykrete, a composite of 14% wood pulp and 86% water. By freezing this specific mixture, the engineers discovered they had created something far more resilient than standard ice. While a block of pure ice would shatter under the impact of a bullet or the pressure of an explosion, Pykrete was tough enough to stop a high-caliber projectile and absorb the shock of a torpedo with minimal damage. It was, for all intents and purposes, bulletproof ice. The wood pulp created a fibrous mat that insulated the inner core and prevented the rapid melting that would doom a natural iceberg. At a crucial demonstration held at 2 p.m., during the Quebec conference, a block of Pykrete famously survived a gunshot that would have shattered ordinary ice, proving to the Allied leaders that this was not merely a scientist's fantasy. But building a ship of this magnitude was only the first hurdle. Keeping it frozen in the middle of the Atlantic Ocean was the true engineering nightmare. The blueprints called for a hull 40 feet thick, hollowed out to contain vast hangar decks, crew quarters, and fuel stores. To prevent the structure from turning into a massive slushy mess, the design incorporated a complex internal refrigeration system. A network of thousands of miles of steel pipes would snake through the Pykrete, circulating cold brine at temperatures well below freezing. These pipes were fed by massive refrigeration units that would have to run 24 hours a day. Imagine a floating city that was essentially one giant, self-cooling freezer, housing 200 Spitfires and several thousand sailors in a labyrinth of sub-zero corridors. Moving such a gargantuan mass presented its own set of problems. Standard rudders and internal propellers were deemed insufficient for a 2-million-ton island of ice. Instead, the engineers proposed a series of 26 electric propulsion units mounted in external nacelles along the sides of the hull. This would allow the ship to be steered by varying the thrust of individual motors, much like a modern drone. The target speed was a modest 7 knots, which sounds agonizingly slow, But for a mid-Atlantic refueling station that could shrug off the most powerful German U-boat attacks, speed was a secondary concern. The goal was to provide an unsinkable landing strip in the middle of the mid-Atlantic gap, the deadly stretch of ocean where Allied convoys were most vulnerable to the wolf packs. The internal structure was a marvel of insulationed technology for its time. To protect the crew from the biting cold of the hull and to keep the heat of the engines from melting the ship from the inside out, the design called for thick layers of cork and wood paneling. The hangars would be carved directly into the frozen mass, reinforced with steel beams to prevent the ice from sagging under its own weight, a phenomenon known as plastic flow. It was a project that blurred the line between naval architecture and civil engineering, more akin to building a mountain than a boat. As we look back at the detailed schematics of the Habakkuk, we are forced to confront the staggering audacity of the era. It represents a moment in history when the survival of the free world was so precariously balanced that the most brilliant minds were given the resources to chase a dream of frozen steel. The Habakkuk was never completed, eventually falling victim to the rising costs of steel for the cooling pipes and the rapid development of longer-range aircraft that made its existence unnecessary. Yet, its legacy lures as more than just a footnote. It stands as a testament to the human spirit's refusal to be bound by the conventional. It reminds us that when pushed to the brink, humanity does not just search for existing solutions, it invents entirely new realities. The ice leviathan remains a silent, ghost-like monument to the power of imagination. A reminder that even in the face of total war, the boldest ideas are often the ones that leave the deepest mark on our collective memory. August 1943, Quebec City, Canada. Within the fortified walls of the Citadel, the Allied High Command gathered for the Quadrant Conference, a summit intended to finalize the invasion of Europe and the defeat of the Axis powers. While the world's attention was fixed on the grand strategies of land and sea, a strange and frozen specter haunted the corridors of power. Project Habakkuk, the ambitious plan to build a massive aircraft carrier out of ice, was facing its moment of truth. Winston Churchill remained a vocal champion of the project, but as the sun crossed the meridian at 1 p.m. on the third day of meetings, the cold, hard data from the Canadian wilderness began to tell a different story. The dream of a floating island was beginning to thaw under the pressure of reality. The first major obstacle was not the melting of the ice itself, but the way it behaved under its own immense weight. Scientists had discovered a phenomenon known as plastic flow, even with the addition of wood pulp. A structure as large as the proposed 2-million-ton carrier would slowly deform over time, sagging and losing its shape like a giant frozen block of taffy. To prevent this, engineers realized they would need an internal refrigeration system of staggering proportions. By 2:15 p.m. during a technical briefing, the sheer scale of the requirement became clear. The hull would need to be interlaced with miles of steel piping to circulate sub-zero brine. This revelation struck at the very heart of the project's purpose. Habakkuk had been conceived as a way to save steel for the war effort, yet now it appeared that building an ice ship would require almost as much specialized steel and machinery as a conventional fleet carrier. The financial burden was equally chilling. What had begun as a radical, low-cost experiment was spiraling into a logistical nightmare. The estimated cost of a single Habakkuk vessel ballooned from an initial few £100,000 to over 10 million. As the Allied war machine reached its peak, every ton of steel and every hour of labor was a precious commodity. The British Admiralty, always skeptical of Geoffrey Pyke's more eccentric ideas, began to argue that the resources would be better spent on traditional escort carriers and destroyers. The complexity of the refrigeration plant, the need for a massive outer layer of cork insulation, and the sheer difficulty of constructing such a behemoth in a secluded Canadian lake were making the project an impossible luxury. While the engineers wrestled with the ice, the strategic map of the Atlantic was changing. In the early days of the war, the mid-Atlantic gap was a graveyard for Allied shipping, a place where U-boats operated with impunity. But by late 1943, the gap was closing. The arrival of the very long-range B-24 Liberator meant that land-based aircraft could now cover almost every square mile of the ocean. Furthermore, at 4 p.m. on an October afternoon, a critical diplomatic breakthrough was reached. Portugal agreed to allow the Allies to use airfields in the Azores. This eliminated the need for a mid-ocean refueling station almost overnight. The geographical necessity that had birthed the ice carrier simply vanished. By December 1943, the decision was finalized. Project Habakkuk was officially terminated. The prototype at Patricia Lake was abandoned. Its expensive refrigeration units hauled away, leaving the frozen shell to face the Canadian summer alone. It would take 3 full summers for the last of the Pykrete to melt and sink into the dark waters. A quiet for a project that had once promised to revolutionize naval warfare. The story of the ice aircraft carrier serves as a profound reminder of the thin line between madness and genius. It represents a period in history when the stakes were so high that no idea was too strange to consider, and no vision too bold to explore. Though Habakkuk never saw combat, it remains a monument to the audacity of the human mind. It teaches us that progress is often built on the foundations of failed experiments, and that the courage to think beyond the possible is what ultimately shapes the future. In the silence of Patricia Lake, the remains of the frozen giant remind us that while the ice may melt and the steel may rust, the spirit of innovation is a fire that can never be extinguished, continuing to light the way for those who dare to dream of the impossible. December 1943 at Patricia Lake, Alberta. The silence of the Canadian Rockies was broken only by the cold wind whipping across a skeletal structure that should have changed the world. What remained of the small-scale prototype of Project Habakkuk was left to the mercy of the elements, a strange congregant of wood, refrigeration pipes, and melting ice. The British Admiralty had finally pulled the plug, realizing that the shifting tides of the Atlantic War had reared their frozen Leviathan a relic before it ever cleared a single wave. But to look at Habakkuk simply as a failed experiment is to miss the profound truth of what it represented during the darkest hours of the 20th century. It stands as a monument to that peculiar, flickering boundary between wartime ingenuity and desperate folly. When Geoffrey Pyke first proposed a ship made of ice, the suggestion seemed like the punchline to a joke that no one was in the mood to hear. Yet by 2 p.m., on the day the plan reached the highest levels of the British government, it was being treated with the gravity of a holy crusade. This was the era of the Great Atlantic Gap, a time when the ocean was a graveyard for merchant sailors, and the U-boat was an invisible executioner. In such a landscape, the traditional rules of engineering were discarded in favor of anything that offered a glimmer of hope. Project Habakkuk was born from the realization that if the steel of the world could not protect the convoys, perhaps the very elements of nature could be harnessed instead. History often remembers the victors and their polished machines, the Spitfires and the Shermans that rolled off assembly lines by the thousands. We rarely dwell on the ghosts of the drawing board, the projects that were too big, too strange, or too expensive to survive the transition from imagination to reality. Habakkuk was all three. It was a vision of a floating island, a berg ship that would dwarf the greatest dreadnoughts and withstand the impact of a dozen torpedoes without flinching. It was a testament to the fact that during wartime, the human mind enters a fever dream where the impossible becomes a legitimate tactical option. Yet, as the prototype at Patricia Lake began to sink slowly into the depths, it signaled more than just a logistical failure. It marked the moment where technology finally outpaced the need for such radical desperation. By the time the engineers realized that a full-scale Habakkuk would cost more than an entire fleet of conventional carriers, the long-range B-24 Liberators were already closing the gap in the mid-Atlantic. The miracle of Pykrete was no longer a necessity. It was a curiosity. The project was abandoned not because the ice failed to hold, but because the world moved on. As we look back through the lens of history, we see Habakkuk as a symbol of the sheer audacity required to win a total war. It reminds us that progress is rarely a straight line of successes. It is a jagged path littered with the wreckage of ideas that were either too early for their time or too wild for the world to sustain. There is a certain beauty in the folly of the ice carrier. It reflects a moment in history when the British Empire, backed against a wall, refused to accept the limitations of physics and materials. They were willing to build a mountain of ice in the middle of an ocean if it meant one less ship went to the bottom. Today, if you dive into the frigid waters of Patricia Lake at 11 a.m. on a clear summer morning, you can still find the twisted metal and the remains of the wooden hull resting in the silt. It is a quiet, underwater cathedral dedicated to the dreamers and the eccentrics who believed they could freeze the tide of war. It teaches us that the spirit of innovation is not defined by whether a project succeeds or fails, but by the courage to ask, what if, when everyone else is saying it cannot be done? The legacy of Project Habakkuk is not found in naval doctrine or ship design, but in the enduring power of human imagination. It serves as a reminder that in our greatest struggles, our most potent weapon is not always the steel we forge, but the boldness of the ideas we dare to entertain. While the ice of Habakkuk has long since melted into the Canadian wilderness, the flame of that ambition remains. It is the same fire that drives us to reach for the stars and to solve the unsolvable problems of our own age. We find our way forward not by playing it safe, but by occasionally attempting the impossible, leaving behind monuments of our ambition for future generations to wonder at. In the frozen giant of the Atlantic was not a failure of engineering, but a triumph of the human will to survive against all odds.